So in this BGP Advance class 4, what we are going to learn is about two things like allow AS override. Two commands. Allow AS, allow autonomous system, or autonomous system override. Now where to use this? In what situation we use this? Now if you see here, we have router 2 and router 4. They are in the perimeter. They are the provider edge routers. Router 2 and 4 are the provider edge routers. So let me name this as provider edge, PE. I'll call it as PE1, and router 4 is the PE2. So we got two provider edge and two customer. But unfortunately, these two customers, this is actually not two customers, this is one customer, and they do not want to have different autonomous system number. Two autonomous system of same customer in different location. They got same autonomous system number. They don't want to change the autonomous system number. So what happens is, from R5, autonomous system 1, the routes are getting into VPN, MPLS VPN. It comes to R2, but from R2 it is not given to R1. The reason is R1 rejects the update because of the same autonomous system coming in the AS path. So R1 will not accept the update coming from R5. Because R5's update has got AS number 1, R1 is also in AS number 1. Now it's good actually. It is good that it is rejecting. Why? In eBGP, the loop prevention is based on the AS number. It is ignoring, or it is rejecting the update in order to avoid loop. It is good. But in this case, it is not good. In our scenario, it is not good. So in order to override this, there are two ways to override this, or in order to solve this problem, there are two ways. One, you can say allow that AS. You can say allow the AS. The other one is you can say AS override. What it means, AS override. On R2, I'll say AS override. When I say that, when an update comes from AS1, from router 1 or router 5, it will not be sent as AS1. Instead, it will be overwritten as 234. It overwrites the autonomous system number so that it can be accepted. A kind of natting. Here, what is getting natted is the autonomous system number is getting natted. So R1's autonomous system number is 1. Actually, it is 1. But update going from AS1 will go as AS1 up to R2, and R2 what it will do, it will rewrite. It will swap the AS number. It will swap 1 with 234 so that it will be accepted on R5 and vice versa. So these two things we are going to see now. For that, let me do the basic configuration. R1's basic configuration looks like this. So I'm forming eBGP with R2, and let me paste this. I'm advertising 1.1.1.1. Going to R1. Done. Similarly on R5, I'll have 5.5.5, and serial interface is 1/0 45.5. BGP neighbor is 45.4. Network that I advertise is 2.5.5.5. Done. I'll paste this on router 5. Next is on R2. I got a loopback 2.2.2.2 and I got a fast Ethernet whose IP address is 10.23. Sorry. IP address is 10.23.0.1 255.255.0.0. I'd like to run OSPF here. Oh good, it's 2. I would like to make it as 2. IP OSPF 1 area 0. I also like to run OSPF on loopback, so I'll say IP OSPF 1 area 0. And also I would like to run VRF, so for this customer, so I'll say IP VRF cust route distinguisher 1:1 route target 1:1, and I'll go under the serial interface IPVRF forwarding cust, and then I assign this IP address and I say no shutdown, and we have BGP will have 234 and the neighbor will be 12.1 and remote AS is 1, and I am not advertising any network here. And I need to form neighbor with VRF, so address family IPv4 VRF cust. Under this I'll activate this neighbor. Right, so this is for eBGP. For iBGP, I have a neighbor which is 4.4.4.4. I am doing iBGP with router 4 for MPLS VPN. So I'll say remote AS is 234 and with the same neighbor I need to send with the update source. Loopback 0 and also to the same neighbor next up self. Actually this is not needed. Nothing wrong in giving also. So what else? This is done, this is done. So MPLS I would like to run. So I'll also say here MPLS IP. So MPLS need to be enabled on the interface F00. So on serial we don't run MPLS because it's customer facing interface, and on serial interface I have IP address 12.2. That's all here as for now. Later we'll come and form a VPN. First of all let me paste this. So this is on router 2. Right, there is a mistake I see in my notepad, that is I have not given space for the loopback IP address. So let me paste one more time. This time it is neat. But still I do see a mistake. What is that? Here this one should come under address family. Right now I'll again copy. Perfect. Alright, I'm expecting a neighbor between R1 and R2. Let's see. If neighbor comes, then VRF is good. Yes. I see a neighbor 10.12.0.1, which means VRF is also good. Show IP VRF VRF. I can see VRF 111. Show IP route VRF cust. I see the routing table. Through BGP I'm learning this, so I can ping now. I'm not pinging. The reason is I'm not sourcing with the VRF routing table, so I'll source it with VRF. Am I able to ping? Right. So now similar configuration goes on router 4. So on router 4 what we have is the same VRF MPLS. The loopback address will be 4.4.4.4, same OSPF, and F00 will have a 24.4. Serial 1/0 has got 45. 45.0.0.4, and neighbor is 2.2.2.2. No, with router 2 we are doing IBGP. And then for eBGP we are doing under address family because it is under VRF, so it will be 10.45.5. I also would like to add one more thing, that is address family VPN v4 unicast, under which I would like to activate this neighbor. Alright, so that's it. I'd like to paste this now. On router 4. Alright, so I'm expecting two neighbors, no, one neighbor now, because R3 is not at configured. I'm expecting a neighbor from R5. Show IP BGP summary. Oh, the mistake is this, no, this is not a mistake actually. I'm expecting now show IP, show BGP, VPN, v4, unicast. All summary. Okay, look at this. We have already formed neighbor with R5. Now let us try pinging. Ping 5.5.5.5 with VRF. Alright. So the ping is not happening means what? So we need to check. Let me check. Show IP route VRF cust. which means that R5 is not advertising. No, it is advertising. Let me show IP BGP. Yeah, we are learning, but the problem is 10.45.0.5. Why it is reachable? No ping. No, it's a BGP small protocol. No, sorry, slow protocol. We need to wait. So I have to wait for this ping to happen. See, it's pinging. So we got the VRF configured. We got MPLS. We got OSPF. Now let me go to router 2 and finish that VPN configuration. So I'll say address family VPN v4 VPN v4 unicast, and then the neighbor is 4.4.4.4 activator. Now, and also I would like to check the OSPF router ID, show IP OSPF, and I want to see the router ID for OSPF here. I was expecting this. I don't want this to be the router ID, so what I'll do is I'll clear the OSPF process, clear IP OSPF process, show IP protocol. In OSPF, I'm expecting the router ID to be the loopback. Still, it is not changed. Router OSPF 1, router ID is 2.2.2. So this will be more easy for MPLS to form neighbor. Now, yeah, we can give explicitly. We can give explicitly the interface. Okay, so next is on R3 I would like to configure. So there is no BGP there, so I'll do fresh enable config t interface f0/0 no chat. One more thing, MPLS IP, and MPLS IP. I also want to have a loopback interface, loopback 0. IP address is 3.3.3.3. Zero, and here next is IP address is 10.23.0.3. IP OSPF area 0. Similarly, we got another interface called f0/1. So I'll copy this and paste it here and make this a 0/1 24.3 and write to memory. There is no BGP, so copy, paste it on router 2, router 3. Now what we are expecting is 2 OSPF neighbor first, 2 OSPF neighbor between this. One is already done and that one is also done. Now I'm expecting a BGP between router 2 and router, yeah, that is, I'm expecting a BGP also. Now MPLS I see, okay, BGP neighbor also has come. Alright, so VPN is good. Router 3, okay, so I got VPN, so let us check the VPN now. Show IP route VRF cast. Wonderful. You see, we are receiving route in our pipe, in our VPN. the routes that is coming from remote AS as well as the local AS. So this is coming from the customer in the left. This is coming from the customer in the right. Show IP BGP VPN v4 all. We can see that this is coming from the remote autonomous system, that is also 1. AS path is 1, and this is also coming from 1. Now when I go to router 1 and type show IP route, I am not seeing 5.5.5.5. Router 2 is getting, but router 1 is not getting. Similarly, if you go to router 4, show IP BGP VPN v4 VRF all, VPN v4 all, I can see that 1.1.1.1 is coming all the way down to R4. It is also coming from autonomous system 1, but it is not given to R5. The reason is same. What is the reason? The reason is the update is coming from the same autonomous system number. The AS path has got the same autonomous system number. Now to override this issue, there are two solutions to override this problem. One, by using the allow-as command. So what I'll do is I'll go to router 5, or before that I'll do debug and show you. Debug IP BGP all updates. And for making it effect, I'll say clear IP BGP star so that I can show you the update. I think it is already. Let's go to the top. What I'm expecting is I'm expecting to see that denied. Look at this. Update is received from 10.45.4. What is the update? Update is about 1.1.1.1. Denied due to AS path containing its own AS. Denied due to AS path containing its own AS. It's very clear. So what we will do is we'll go to router 5 and say router BGP 1 in R5. In R5 we say allow, because here only it is denying, right? So we will say neighbor 10.45.0.4 allow AS in. Allow AS in. So now what I'm expecting is show IP BGP. Look at this. 1.1.1.1 is allowed in, though it is coming from the same AS. You see, same AS number, the local AS and this AS. It is allowed. Show IP route now. I got it. Wonderful, right? Go to router 1 now. See, on router 1 I am not seeing 5.5.5.5. So what I'll do? I'll go and say router BGP 1 neighbor 10.12.0.2 allow AS in. So you don't need to even refresh. You can immediately see the route. Wonderful. So show IP BGP. I can see that 5555 is coming from AS1 and R1 is also in AS1, though the AS number is same, but still it is allowed. Now let us try pinging it. Ping 5.5.5.5 with the source of 1.1.1. We are able to ping. So this is one solution when the same AS is not allowed. Now I'm going to delete this and put the other solution. I'm going to delete this allow AS from both the router R1 as well as an R5. Right now, if you go and ping from R1, you should not be able to ping. See, the ping is not happening. Same AS, not allowed. So both the side I removed. Show IP route. No, don't have 555. Show IP BGP has no update for 555. So the next solution is AS override. For AS override, what you do is you go to the PE router. On the PE router, router BGP 234 and address family IPv4 VRF cast. Here you do override. What's the command? Neighbor 10.12.0.1, that's the neighbor address, autonomous system override. How easy it is. PE router. So what, you know what PE will do? PE will overwrite autonomous system number. It will remove AS number 1 and it will send update that is coming from AS number 1 as if it is sending from itself. So let us go to R1 now and clear IPBGP star. You see, you can see that 5.5.5.5, it is overwritten by its own. This is the actual, this one has been replaced by replaced as 2, 3, 4. So if I check in the routing table now, show IP route, I'm able to see 5.5.5.5. Similarly, I'll go to router 4. And right now, before going there, I'll show you the status on router 5. Show IP route, there is no 11111. So go to router 4. Router BGP 234. Address family IPv4 and neighbor, sorry, I missed VRF cast, and then here I say neighbor 10.45.0.5 AS override. So now, if I go to router 5 and check the routing table, I should get the route very shortly, but I need to clear the BGP session. Clear IPBGP star. Show IP route. Yeah, I got 1.1.1.1. Let's check the BGP table. Show IPBGP. I can see that it has overwritten. One is overwritten as 2, 3, 4. I'm waiting for 5.5.5.5. 5.5.5.5 is local, so I'm waiting for that. It will take some time. BGP is a bit slow. On router 1, okay, I got 555 on both sides. Now I can ping 5555 with a source of 1.1.1.1. It's pinging. So hope you understood this allowas-in command and then AS override. By this, we are finishing our BGP Advance topics. Tomorrow we will be getting into some other fundamentals of BGPs like communities, and we will also be discussing about attributes and so on.